Okay, welcome everyone. Today I want to talk about how cloud can help astronauts and scientists execute missions into space.
That's right.
And to help me do this, I'm joined by Clint Crosier, who is the Director of Aerospace and Satellite Solutions for AWS.
Mm-hmm. Thank you for having me today. Thank you.
Thank you for joining.
My pleasure.
Maybe you can give us a bit of your background, because
Sure.
it's quite interesting how
Sure.
you ended up at AWS.
Well, I've been very fortunate in that I've been working in the space business for 35 years. So straight out of college with an aerospace engineering degree. And by the way, the U.S. Air Force paid for my engineering degree because it needed more people with STEM backgrounds. And so we have some wonderful programs in the U.S. government to pay for people's education to go into STEM. And I was the benefactor of one of those. So coming out of college, I had an opportunity in the Air Force to get into the space business. And so I spent 33 years essentially flying satellites and launching rockets for the U.S. Air Force and other agencies that the U.S. Air Force participates with. So I used to command the global GPS satellite constellation. So everybody in the world uses GPS. I used to go to work every day as the commander of the organization that operates the global GPS satellite constellation.
That's amazing.
I've launched rockets out of Vandenberg Air Force Base, putting satellites in orbit. So I have 7 successful rocket launches putting satellites on orbit. And I've done many other things in between. My last opportunity before I retired, I actually found myself in the position of being the lead planner and the architect of the creation of the new U.S. Space Force, which is the newest branch of military in the U.S. Department of Defense. First new military branch in 72 years. And I was responsible for the establishment of the U.S. Space Force. So that's kind of my background.
That's amazing. It's such a cool black background.
Yeah, thank you.
I actually recently interviewed Chris Hadfield for my channel, who is a very famous Canadian astronaut.
Yes,
so
yes.
He was the commander for the International Space Station.
Yes,
so,
wonderful.
Yeah, it was great. We talked about how the role of technology in space. So
amazing technological revolution going on in space right now today. And that takes me to my role here at Amazon, frankly. I really appreciate Amazon's vision. 2.5, 3 years ago, Amazon looked across, AWS in particular, looked across the space and aerospace industry and saw the rapid growth by any measure, whether it's the number of satellites being launched every year, and experts would tell us there'll be 5 to 10 times more satellites launched over the next decade than over the last decade. Extraordinary. Whether you look at the number of countries that are moving into space, and there are some 70 or 80 countries that are operating space capability around the globe today, or whether you look at the economic value. And Goldman Sachs and others tells us the space industry will be $1 trillion industry by 2040. And so AWS saw that coming and recognized how valuable advanced cloud technologies can be to this highly complex environment of space. And so they determined to stand up an organization focused solely and specifically on bringing cloud capabilities to the space industry.
wow.
And so I was in a position where I was retiring from the U.S. Air Force and the U.S. Space Force, and they reached out to me and asked me to help establish this new space-focused cloud business. And so I have the best job in the world, bringing advanced cloud technologies to space organizations around the globe.
Very good. So from your perspective then, what are some of the biggest opportunities? What are you excited about when you think about space and satellites?
So the biggest opportunities, I think, are solving problems associated with space, and that's a big part of what AWS does. AWS is about identifying our customers' friction points, challenges, problems, and then finding cloud-based solutions. So as somebody who's operated satellites my whole life, you know, one of the biggest problems we have with satellites is when we launch them, we really can't reach out and touch them again after that, right? So my whole career, when you launched a satellite, the capabilities it had on board is the capabilities it had forever. And so that's been a limitation. The other limitation is downlink capability, right? We've just got limited comm pipes, and there's a limit to the amount of data that we can push down without other trades. That's why I'm so excited about an announcement that we made yesterday, where we sat down with one of our customers, D-Orbit, and D-Orbit suffers those same challenges with the limited bandwidth and lack of processing power in orbit. And so what we did, D-Orbit does hyperspectral imagery, so it takes pictures of the Earth, and then it'll download those images to the Earth and then process them in the Earth, only to determine that some 20 to 30% of them might be unusable due to things like cloud cover and smoke cover if it's a fire area that you try. So they're taking pictures, spending the bandwidth, the time, money, and effort to download them, process them, only to find them not being usable. So what we did is we worked with Deorbit, and we built a machine learning cloud computing package specifically built for the space mission, specifically built to operate on an orbiting satellite in space, and it's now pre-processing the data. So it's comparing the images as they're taken to specific requirements, and if the image isn't usable, essentially, it'll throw them out and take a different image somewhere else on the globe. And so what we found is with this on-orbit processing, we've reduced the data downlink requirements by 42%.
Wow.
That's powerful.
Yeah.
And so not only have we reduced the amount of data you have to push to the Earth, but the corresponding cost, both in terms of money and other bandwidth, is a big savings. And the other piece, if you think about it, if 20 to 30%, a satellite's like a camera. It has a limited amount of storage space to take photos of the Earth. And when you download, if you find that 20 or 30% of them are unusable, you're only using 70 or 80% of the capacity of the satellite. When you pre-process and do a threshold requirement and throw out the bad ones, now you're going from 70 images, making up the number, to 100 images on a given satellite. So you've essentially increased by 30, 40, maybe 50% the capacity of imaging capability on a satellite. So there's a couple of powerful innovations here that we're really excited about with this experiment. Specifically to your point, addressing problems and challenges with operating in the harsh space environment and using cloud-based technologies to address those problems.
Very good. So that are they edge computing solutions
that
sit on the satellite?
That's right. Edge computing that sits on the satellite. So compute and machine learning. And what's powerful about that is in my day, initially, when I was a young officer flying satellites, we had no processing capability at all really on satellites. Today we have some processing capability. But what we've done by doing all this in a cloud-based environment, you can train new ML models, you can train new capabilities inside the AWS console here on Earth in your normal applications. And then when the satellite comes overhead, you can just upload with a couple of clicks on your laptop in your AWS console and add new models or new training or new capabilities to the satellite as it comes overhead. That's a first, and that's a powerful innovation.
Yeah, it's great. So we talked about satellites, astronauts. How can they benefit from cloud computing?
So we were here at REMARS in Las Vegas back in June. I was in the team, and we made another announcement at REMARS. We announced that we took a snow cone, which is a commercial off-the-shelf edge computing device that any business or company can order today and use as an edge capability for your business. But we took a commercial off-the-shelf snow cone. We took that to NASA and we went through a 7-month space flight qualification testing program with that commercial off-the-shelf. Now, it was built to be ruggedized, so you could put it out on trucks and ships. We didn't know when we built it we could get it through the NASA space flight certification, shock testing, vibration testing, thermal testing, right? All these sorts of things. And so Axiom Space, a company out of Houston, Texas, worked the integration with us. They launched it into space on their AX-1 launch and then brought it on board the International Space Station. And then so the astronauts on the International Space Station used that edge processing device to manage 18 experiments that were being conducted on the International Space Station at the time. And I'll give you an example of why that's so powerful. A standard medical experiment. As you probably know, the medical community knows and understands that there are certain experiments you can only really run in microgravity with better efficiency and effectiveness than on Earth. And so we run a lot of medical, stem cell and others. A standard activity was they'd spend an hour to run an experiment, and then given the limited bandwidth, would take up to 18 hours to send the data from the experiment down to Earth, process it in the AWS cloud in 20 or 30 minutes, and then upload the results back to the ISS, and the astronauts would go a full day in between consecutive experiments. With that snow cone on orbit, now astronauts can run an experiment, run the processing on the ISS in 20 minutes, and load up the next experiment. You're essentially increasing by 20 times the amount of science time on board the International Space Station. So when you start to move edge computing and cloud computing capability closer to the workloads, and in my case, my customers happen to need the workloads in space, you're really improving efficiency, improving capability, and greatly reducing cost. And so it's really exciting.
Yeah, very. So what are some of the biggest challenges then when it comes to space and using cloud and edge computing?
Yeah, some of the biggest challenges are what we've identified. Space is a harsh environment. There's radiation, there's thermal, there's acoustic, there's vibration, just getting it onto orbit, right? Sometimes things break on the way to orbit because it's a challenging environment. It's a violent environment to send a rocket from Earth into space. That ride in between is the hard part. Once you get into space, that's the relatively easier part. Then you've got other things to worry about, like thermal and radiation cycles and those sorts of things. But so that's one of the challenges. But with the International Space Station, it's human rated, right? So we didn't have to do a whole lot of special things, really nothing special, to the snow cone. When we moved over to the experiment on the satellite, now you're exposed to the very harsh elements of space. So you have to take into account all the difficult operating environment conditions of space. And that's why we couldn't use a commercial off-the-shelf capability for this experiment with deorbit. We had to build a purpose-built hardware, software capability that could run on a much smaller device. The satellite, about half the size of this table, is a much different environment than inside the large International Space Station. So some of the challenges are the harsh environment and the fact that it's so distant and it's difficult, there's no screwdriver long enough that you can reach up there and adjust it, which is why it's so powerful to be able to run and train things in the cloud using modeling and simulation and application architecture, and then with a couple of clicks of the button, upload it to the orbiting spacecraft.
Very good. So what's next then? What's on the horizon in terms of space solutions and aerospace and satellite solutions within AWS?
So NASA and 21 countries around the world have entered the Artemis Accords, and Artemis launched just last week, a successful launch and a lunar probe deployment. And there are 21 countries around the world that are involved in the Artemis Accords. And the aim of the Artemis project is to go back to the moon, eventually putting the next man and first woman on the moon and many other firsts, beginning to create a lunar encampment or a physical presence on the moon, and then push off with human exploration of Mars. So I'll put a pause right there. Then you think about when I have an orbiting space station, I have the ISS today. Tomorrow, Axiom, who I mentioned we did the experiment with, has a contract to build a commercial module to attach to the International Space Station. So now you have a commercial platform in low Earth orbit where you can run other commercial activities. And Blue Origin, who we support, has announced they're building Orbital Reef, which is a LEO commercial space station. And so this is creating the environment where now we can go out and do maintenance and servicing the satellites. You can use the space station as a platform to go out and capture a satellite, replace a solar array, refill the propulsion system. You can start building satellite components on the space station and even building satellites on the space station so we don't have to launch them from the Earth. We've got asteroid mining, we've got all sorts of things that we're seeing. All of those are going to require additional automation, additional robotics, additional AI and ML capabilities. So we've done experiments on the ISS with a commercial off the shelf. We've done a purpose-built cloud edge computing on a satellite. As we see all these missions emerging, we will continue to work with customers to provide the cloud-based capability when they need it and where they need it to address their specific challenges in space.
Wow. So what are your personal hopes when it comes to space exploration?
Yeah, well, I love the idea that we're going back to the moon, and I love the idea that we're going on to Mars. And sometimes people ask, hey, we're spending a lot of money to go to the moon and to Mars. Is that the best use of the money? And I will tell you what I love, and when you explain this to people, they really get it. Space exploration is powerful in helping us build technology, identify technology. But what we've seen over the last decades, with all the things we've learned from operating in space, we've started turning those capabilities and focusing back on the Earth. And so now we're running a mission that I call Making the World a Better Place from Space. And that's how we're using satellite imagery to do wildlife management, climate management, maritime safety and security, agriculture support and supporting the crop development industry, insurance, oil and pipeline gas production, supply chain management and logistics. So we're seeing so many ways that we can use space-based data on top of the space exploration piece to improve life here on the Earth. And so I'm excited simultaneously about helping NASA and the Artemis Accords and others really push the boundaries of human exploration in space, while at the same time we continue to work with companies here on the Earth to exploit satellite data in new ways to help make life on Earth better. So those are two key goals that we have.
Super interesting. Thank you so much for sharing this with me.
Yeah, thank you.
That was great.
Thank you. Thank you for having me.
Yeah, pleasure. And anyone who ever wants to re-listen and re-watch this, head to my YouTube channel where you can find this and hundreds of other conversations like this, including the one with astronaut Chris Hadfield. So see you soon.
Thank you.
Thank you.
Thank you very much.